Okay, so a quick review from your primary trig using SOHCAHTOA. So we label according to the angle we're going to use. So 8 is opposite of angle x. And you can see 14 is hypotenuse. It's directly across the right angle. So you look at SOHCAHTOA. So op and hype, and they want us to find x, the angle, so we have to use sine. So sine x equals opposite over hypotenuse. And to find the missing x, which is the angle, you have to use second function sine of the ratio. Okay, so I'm getting 35 degrees. Okay, let's take a look at question B. Directly across 40, you have your op. Directly across the 90, you have your hype. And 19 is your adjacent. Say that again. We're not looking for the angle on this one. We're looking for the length of the hypotenuse. No worries. So now this formula, it wants, or this question, it wants x, but you don't have any knowledge of op. So if you don't have any knowledge of op, the only formula that you can work with is cosine. So cosine of 40, you always put the angle next to the cos, and then you put the adjacent divided by the hypotenuse, which is 19 over x. And then you can cross multiply x and cos 40 switch places, and you have 19 divided by cos 40. And you get 24.8 for a side length of x. Okay, this is right angled trig from math 10. Used to be math 9. Okay, in math 11 here, we are going to be using triangles that are not right angled. So you're going to use the sine law. Okay. Okay, so I don't want to do any more SOHCAHTOA. We're going to skip the proof of the sine law. It's just a little bit too much. We don't need the proof. Basically, all that the proof does is it shows, it takes a non-right angled triangle, it uses the height, which creates two right angled triangles. It uses SOHCAHTOA to build this new formula that you're going to use called the sine law. Okay. So we'll start on class example 4. The sine law goes like this. So we'll start on class example 4. It's going to be a over sine A equals b over sine B equals c over sine C. Okay? So take a look at your formula sheet. Look at the back of your book. Look at the back of your book in the inside cover. Do you see that formula anywhere? In the trigonometry section? Okay, so there's your sine law, okay? And it doesn't matter if you put the little ABC on the bottom. Okay, you could also write it like this. You could put sine A over little a equals sine B over little b equals sine C over little c. It doesn't matter how you do it. So just pick one and stick with it. It doesn't matter. Because they're just ratios, okay? And these ratios, obviously you're not going to do 3 at a time. That doesn't make any sense. So you just, do 2 at a time. Do 2 at a time. Okay? And all it is, you guys, is cross multiplying. That's how you solve. It's very, very straightforward. Okay? Now, what is this little a, little b, little c, and what is capital A, capital B, capital C? Okay? So take a look at your diagram. For like these triangle geometry, if you will, the vertex the vertices are capital letters, and if you go straight across, you get the lowercase, and that's just a convention. So if capital A is down in the corner, this is little a right here. And I'll get this stuff out of the way. Okay, so if this is capital B up in the top corner, go straight across from that, and 6 is your little b. Okay, and then if C is in the bottom right, then go straight across, you get little c. Okay, so if you want, you can draw these arrows like this. To show that relationship. So just go straight across. Okay. So what information do we know? Absolutely everything about. We know about A. Okay. And what's the other one we know about? We know about B, right? So B's here. So the only one that we can solve for right now is B, capital B. Okay? So we like to put, it'll be like this. B over sine B equals A over sine A. That's what we're going to use because C is all unknown. So you can't work with C right now. You can't work with C at all. Okay? You can only work with B and A. Now for this fraction equals fraction, and to solve stuff like this, you always just cross multiply. You have to know 3 of the 4 to get the missing. So what 3 do we know? Little b is 6. Sine b is unknown. Little a is 9.4, and you have sine 110. Any questions so far? Any questions? You okay, Carl? Okay, so we want to isolate for this one here. So we cannot isolate it if it's in the bottom. It has to be in the top. Okay, so if I want sine B in the top, it can only go to one spot and one spot only. Up there. Okay, it's called cross multiplying. If it's dividing on the left, it's timesing on the right. It's complete opposites, right? I think most of you know this already. So I need sine B to be alone. So when it goes up there, there's other stuff in the way, right? This 9.4 is in the way. I don't want it there. So where is he going to go? Down here. I also have this sine 110 in the way. Where is that guy going? Top left. Okay, now rewrite it after the cross multiplication. You'll have, on the left, you'll have 6 times sine 110 all over 9.4, and this equals sine B. Okay, absolutely make sure your calculator's on degree mode. So these crappy ones will say DEG or a capital D, and then for the TIs, the graphing, you have to go in the mode and make sure, check the mode. Okay, so 6 times sine 110 divided by 9.4, I'm getting 0.5998, blah, 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 equals sine B. So just double check that you can execute that with your calculator, that you get the same ratio, this 0.5998 business. And there's one more step. How to isolate from B if it says sine B? Not shift. Yeah, shift on the calculator, but what math word would we use? Not second function, but starts with I. Inverse, good. Inverse function sine of both sides isolates for B, this 998 business. So second function sine that answer, and I'm getting like, I'll round it to the nearest degree, 37. Okay, so we can put 37 up in the spot for B. And then we can also solve for C. How to get C really easily. Yeah, all the angles, you guys remember? All the angles in a triangle add up to 180. So 180, take away 37, take away 110, and you get the angle at C. You guys getting 33? So 33 and 37, that's what you're looking for. Okay. Let's go back to the question. Let's just be careful. And sometimes kids kind of mess this up. They forget from whatever reason, I'm not sure. But it says, determine the measure to the nearest degree. When you look at that symbol, what do you notice? ACB. Which one are they referring to? It's the one in the middle. If it says ACB, they want you to find, I'll write this for you. This means right here, find angle at C. Because the vertex is in the middle when you have this angle notation. Okay, so watch my pointer. A, C, B, they want this angle here. A, C, B, A, C, B. So this angle here. A, C, B. Got it? Okay. Let's try down below. Okay, a surveyor measuring a baseline PQ. So that's straightforward, right? With the notation, you guys okay with PQ? Down, here's this PQ, like line segment PQ. And measurements of a landmark, whatever. Okay, so this is important. Where is QPR? QPR, where do I put 46? In the middle letter, P. Okay, watch my pointer. QPR, that angle's 46. Now what about PQR? 75 is in the bottom right. Okay. Now it wants us to find the perimeter. Okay. What's perimeter? Path around the outside? Okay, total distance around the shape. Okay. To the nearest meter. Okay. So, with the sine law, because we're going to be doing cosine law later, it's important to see like what situation can you use the sine law. So it's like you draw in these like loop-de-loops. I don't know if this helps. And one more. Like this. It's kind of like that nuclear symbol. Kind of. Okay. So remember that the sine law says that, just want to give myself lots of space, sine of, let's just copy what I did above. Let's use A over sine A equals B over sine B. Let's keep it consistent. Now what can I place where? Use my pointer. Where? What can I do with the 440 and the R? They go together. Yeah, so what's little a? 440. And sine A would be, in this case, sine R. You guys okay with that? And now let's choose 46 or 75. Doesn't really matter. You got to get both of them. So let's just go with red. I like red. So, okay. So sine 46 in the bottom, because remember, angles always go with the sine. And then what would go with sine 46? What letter? Little p. Little p. So if you look at this formula, do I have enough information? Don't you need 3 out of the 4? How are you going to get r? So that third angle's for free, right? All of the angles in a triangle add up to 180. So don't forget that. Sometimes that's the key to unlock a problem. So 180 minus 46 minus 75, and that will be this angle in here. 59? Thank you. So now I can change where it says R to 59 degrees. Okay. So now all I have to do is isolate for P. So what do I need to move? And that's it, right, Carl? Because P's already in the top. That's what we want. We always want the unknown in the top by itself. So it's in the top, it's just not by itself. So what do I got to do with this 46 sine? Move it up here. Okay? So we'll have 440 times the sine of 46, all divided by the sine of 59. That's going to give me little p. 440 times sine 46 times sine 59. What'd you guys get? Okay. I'm using a crappy calculator. It's giving me the wrong answer. I don't know. Something wrong. Maybe because I didn't use brackets? I'm not sure. Okay, now I got it. You guys get 369? Okay. Okay, if you don't get 369, please, during the work period, get my assistance with the calculator, okay? And I'll come around and help you guys. Okay, so we got P. It's 369. All we need now is little q. Okay, so I'm just going to switch to green. Okay, so sine of q would go in the bottom here. Sine of 75 in the bottom. Little q goes with that, right? Little q. Little q goes with big Q. So little q over sine 75. And then I'll just use the r again. So 440 over sine 59. Now for this one, how to isolate for q? Throw it up there? Okay, awesome. So q is going to be 440 times the sine of 75, all divided by the sine of 59. And on my scientific calculator, I'm wrapping brackets around sine 75 like I have on the page. Now with the Texas Instruments, it's probably way easier. So I'm getting 495.8, 496. Now to answer the question, which is basically they just want you to get every side, add up all the sides. So 440 plus 369 plus 496, add them all up, and you get the perimeter. So add all sides, and you get 1305. A couple people confirming that. Answer key confirms it. Any questions so far? Can I zoom out? Sure. Whoops. So you guys will find sine law very, very easy. It's like a nice little break from some hard stuff. What ends up happening is at the end of the unit, we revisit the sine law for what's called this ambiguous case. And that's where sine law gets challenging. But hopefully I can give you guys some tips for that. But at this point, we're just going to keep it easy with sine law. Okay, moving on. I think this is the last one, and then you guys will have time to work. Oh, calculate the area of PQR. Oh my gosh. We're not done with this. Okay, so back to this. We need to find the area. Okay, so I'm just going to copy this triangle over here. Just copy the triangle. You can copy mine. R was up here. P is here. Q is here. So we had a 440 down here. We had a 496 here. And we had a 369 there. This was 75 degrees, 46 degrees, and that was 59. So I'm just copying from the last page. We did all this work already. Now for area of a triangle, that formula of course has different variations, but one of the easiest ones to use is just the half AB, because little a would stand for altitude and B stands for base. I think that's the best way to think about this one. Other people, say half base times height or whatever. I think the half AB works really well because it reinforces that you need the altitude of the triangle. Okay. And the altitude is always at a right angle to the base. So this here is the altitude. Or if you're not comfortable with that word, it's the height of the triangle. So in order to calculate the area, we need the height. So it's going to be a half times the altitude, which we don't know, times the base, which is 440. We could have rotated this triangle and used a different altitude, and then used a different base. But right now, with this, the way it's drawn, we have a base of 440. All we have to do is calculate that altitude. And to calculate that altitude, you're going to have to use your basic trig. So if you have a right angle like this, then just use your basic trig. Okay? So how to find the altitude? Well, it's the opposite, right? It's opposite of 46. And we can use 496 as the hypotenuse, so that would be SOHCAHTOA. Sine of 46 equals the altitude, the opposite side, divided by 496. And there's going to be a little bit of rounding error because I rounded 496, but that's okay. So cross multiply and you'll solve for the altitude. 496 comes up. 496 multiplies up. So sine 46 times 496, I'm getting 356. 356.8. Again, I rounded again, so this is going to be off a little bit. Not the end of the world. You get 1/2 356.8 times 440. Divided by 2. I get 78,496. Whoops. 496. And then it wants me to round it to the nearest 100 just to avoid that rounding error. And I get nearest 100 would be 78,500. And the unit for area, square meter, We are done. Okay, lots of time to work, about 25 minutes. So pretty much just master your sine law. And then it's one less thing to worry about. Because that quiz 4 that you just did, I find that, you guys will find that more challenging than the sine law. So let's just get sine law mastered, and then you can go back and revisit some of the older homework that you might be struggling with.